This is the video support for linear algebra for the Mathematical Methods coursework 6G5Z3001. So I'm just going to go straight to the coursework questions. Question 1A is about row reduction. We did cover elementary row operations, and we have done a number of examples in class with row reduction. So you're asked to solve for W, X, Y and Z, and you will solve these equations with respect to the parameter mu. You must remember that, be careful, because you have to solve this system completely. So ask yourselves, what does this mean, solve completely? For question 1b, we need to find a matrix B such that AB is equal to C. You can do this by inspection, but you must show how you find the matrix B. So you have to give a simple explanation as how you found the matrix B. And then to find the determinant, we use the rule that determinant of A times B is the determinant of A times the determinant of B. And if you look in the notes, there is an example on page 4 which shows you how you factorize a determinant, and you'll see that there's a brief explanation here, but we covered this in more depth in class. Okay, question 1c is to do with vector spaces. So this is from chapter 1, and we need to prove that the following subsets are subspaces. So again, we've done a number of examples. So a subspace is defined on page 10, and then there are a number of examples here where we prove that, for in this case W1, for example W1 and W3 in this case are non-empty subspaces, so there are examples there. And then later on we also considered the following, these sets, and again in class I did prove that these were all subspaces. So you need to look at the lecture notes for those examples. Then we need to determine R bases for P1 and P2, and again I found bases for W1, W2, W3 in these examples. Well, I think I did W1 and W2 in the lectures, and I think Saeed will do W3 in the examples class. And then there are other examples in the notes of bases and linear independence, and basis is defined here. So remember, when you're proving that a set is a basis, you have to prove that a set generates, so you have to find the generating set, and then you have to prove that a certain number of these vectors are linearly independent. So you have to find the spanning or generating set for the basis, and then prove that a certain number of vectors are linearly independent. And then for part D, it's from chapter 2 for linear transformations, and we have to determine the matrix of a linear transformation, so little b t b dashed. And for this example, we're going to be looking at the example on page, so it's a change of basis. So we want to look at theorem 2.1. So little b t b dash, you see, is the inverse of q times capital B t capital B dashed p, and you'll see that there is an example, a similar example on page 18. So here is the similar example, and you'll notice here you go from V3R to V2R. Of course, in the coursework you go from V4R to V3R, and we call this a banking question because you'll see at the end here you can check your results. Yeah, and you're also asked to check your results for the coursework, so you should be able to get full marks for this question. Okay, and that concludes the help for the linear algebra question. Okay, good luck.